Welcome to this video. This is actually a continuation of a previous video in which I started solving the math portions of the April 2017 SAT exam. And in the previous video, I did section 3, which is the no calculator portion. Now in this video, I'll be doing the calculator portion. Or calculate aloud, calculate required. I don't know if it's actually required. I think it's not required, but it's definitely helpful to have it for some of the calculations. Okay, so I'm gonna try to solve this all in one sitting. If not, you'll probably see that the video cuts every now and then because I probably stitched a few videos together and I solved it in a few different sittings. So without further ado, let's begin. Let's see how I do. I'm solving this live, by the way. I did not pre-solve any of these. I did not even look at them beforehand. I do have the answer key though. So I'll be comparing as I go along. Okay, number 1. If m equals 3, how much greater is 10m than 6m? So how much is 10m? 10 times 3 is 30. How much is 6m? 6 times 3 is 18. How much bigger is 30 than 18? 12. Answer C. Next, temperature in degrees Celsius of a hot object placed in a room is recorded every 5 minutes. Temperature of the object decreases rapidly at first and decreases more slowly as the object's temperature approaches the temperature of the room. Which of the following graphs could represent the temperature of this object over time? This is, if you know the degrees of cooling, I think it's like Newton's law of cooling, then you know how the graph looks, but you know how the function is modeled. But just by the words here, it decreases rapidly at first, then decreases more slowly. So this is for sure increasing, eliminate. This is increasing, eliminate. Only these two are decreasing. This one's decreasing faster. First, the slope between the points is much steeper than over here. Versus here, it's not as steep and then it gets more steep. So this is cooling faster as time goes on. So it's not this. This is cooling slower as time goes on. So it's this one. Okay, pretty easy so far for the first two. If I can turn the page to the next set. All right. Which of the following values of x is a solution to the equation above? So you could start solving, or you could just plug in the values I would just plug in. So we get minus 3 on the left-hand side, sorry. You can't take the square root and get a negative number for it to be real. Eliminate. Same thing for this. If you plug in x is 1, the left-hand side would be negative. But when we take a square root, the outcome has to be positive. Whoops, I dropped my pencil. Okay, so eliminate. 2 more left. If x is 4, you have 2 here. Square root of 14, that's for sure not that. If x is 6, you get 4 over here. Square root of 16 is 4, which equals 6 minus 2, which is 4. That's right. Okay, that's how I would solve that one. You could square both sides and then do all that shenanigans, but in this one, I feel like plug it in might be faster. Last year, 800 students attended the career fair at West High School. This year, the number of students who attended the career fair increased by 5%. How many students attended the career fair at West High School this year? All right. So it increased by 5%, so it's 800 times 1.05. This is where the calculator can come in. Just punch it in real quick. 800 times 1.05, which is 840. And you're done with this one. All right. By the way, I didn't really explain why it's that. It's 800 and then 5% more. So it'll be 800 plus 800, 5% of that. This is 5% of 800. So if you factor out the 800, it'll be 1 plus 0.05, which is 1.05. That's the faster way to do it. And once again, I feel like I said this in some of my test prep videos. If you go shopping a lot, this is a piece of cake. If you know how to apply the percent change formulas real quick. Okay, 5 and 6 refer to this table here. Table above shows the calories, grams of fat, and grams of protein in 1 ounce servings of selected seeds and nuts. Okay, so number 5. How many more grams of protein are in 1 pound of pumpkin seeds than are in 1 pound of pistachios? Okay. So in pumpkin seeds, I'll write SPS, How many grams of protein are there in 1 pound of pumpkin seeds? So pumpkin seeds, notice they underline pound because this is in grams in 1 ounce servings. So this is 1 ounce servings. There are 16 servings then. Okay, so we need, what's this again? Pumpkin seeds. So this is grams of protein, right? 8.5 times 16. Plug it into your calculator later. You might be able to factor stuff. And you should be able to because it will be multiplied by 16 again. So pistachio, I'll call it PI. Pistachios, there's 3 grams times 16. Okay? So it would be, how many more grams of protein are there in pumpkin seeds? It'll be 16 times 8.5 minus 3. So that's 16 times 5.5. Plug that into your calculator. Again, you could have just plugged in 16 times 8.5 minus 16 times 3, or you can just plug in 16 times 5.5, which is 88. Okay, that's the answer. Let me double check. Yes. Okay. Number 6, Lionel purchases 1 pound bags of each of the 5 seeds, and that's shown in the table. Of the following, which best approximates the average number of calories per bag? Okay, so 1 pound is 16 ounces. Again, so it's asking for average number of calories. Okay, so we would want to sum up all the calories and then divide it by how many entries are there? 1, 2, 3, 4, 5. 5, okay? And then at the end, we can multiply by 16. Or you could do 16 times 198 plus 16 times 80 plus blah, blah, blah. Divide by, how many were there again? 5. That's the same thing as if I find the average of this first and then multiply by 16 at the end. So I'm going to do that way. So 198 plus 80 plus 159 plus 166 plus 185 divided by 5 times 16. Okay, I get 2521.6. Closest answer is D. Okay, let me double check that is correct. Yes, okay. So that's how I approached it. So once again, you can do 16 times 198 plus 16 times 80 plus 16 times 159 plus 16 times 166 plus 16 times 185 all over 5. You would get the same answer. So you can notice that I've orally said 16 times so many times. So you would be punching that into your calculator as many times also. Or you could realize that you can factor the 16 out. And so you could just find the average of all this and then multiply by 16 at the end. That's which is what I did. A little faster, less punching in the calculator. A pool initially contains 1385 cubic feet of water. A pump begins emptying the water at a constant rate of 20 cubic feet per minute, which the following best approximates the volume in cubic feet of water in the pool t minutes after the pumping begins, for t between 0 to 69. Okay, so this is a linear model. So this is the initial, this is like the y-intercept. So when t is 0, you should have 1385. That's all of them are right. So if it's emptying, then you would have a negative slope because the volume should be decreasing. The slope of the line should be negative. These two are positive. You can just imagine when t is getting bigger, your volume is increasing. That's not emptying the pool. Okay? Now, how much is it? It's 20 feet per minute, cubic feet per minute. So the answer should be A. Okay? At a snack bar, each medium drink costs $1.85 and each large drink costs C more dollars than a medium drink. If 5 medium drinks and 5 large drinks cost a total of $20.50, what is the value of C? Okay, so if medium is 185 and large is C plus 185, okay, 5 medium, 5 large costs $20.50. So 5M plus 5L is $20.50. Okay, so it'll be 5 times 1.85 plus 5 times C plus 1.85. I plugged in L. as c plus 1.85 equals 2050. Okay, so you would have 5c plus, this is 5 times 1.85, another 5 times 1.85, so that's 10 times 1.85 is 2050. So c would be 2050 minus 18.5 over 5. So 20 minus, 20.5. I'm plugging into my calculator. 20.5, minus 18.5 divided by 5. C is 0.4. Answer is B. Let me double check. Yes. Kate bought a bus pass that had an initial value of $90. For every bus ride Kate takes, $180, the cost of one bus ride, is subtracted from the value of the pass. What percent of the initial value of Kate's bus pass is the cost of one bus ride? So you want to find it as a percentage, so you just divide the two and then multiply by 100. Okay, so plug that into the calculator. 1 divided by 90 times 100, that'll be 2%. Answer is B. Okay, moving along. Lots of words here. Let's see. To determine whether residents of a community would vote in favor of a ballot proposal to use 100K for local taxes for additional playground equipment at a community park, Jennifer surveyed 60 adults visiting the park with their children during 1 week in June. She found that 45 of those surveyed reported that they would vote in favor of the proposal. Which of the following statements must be true? So we gotta go choice by choice. Okay, so she surveyed 60 adults, and of those 60, 45 of them voted yes. When the actual vote is taken, 75% of the votes will be in favor of the proposal. We have no idea because the 60 adults she surveyed, we don't know how representative that is of the entire community. How many people are in this community? If it's just 60 people, then she surveyed everyone. Then for sure, A would be true. But let's say this community had like 10,000 people. She only surveyed 60. That's a very bad sample size. Very bad to represent. The 60 cannot accurately, I shouldn't say can't accurately, but very low chance that will accurately represent the entire population. Okay, so we can eliminate A. How about B? No prediction should be made about the votes on the proposal because the sample size is too small. How do we know the sample size is too small? What if the community only had exactly 60 people? She surveyed everyone then. Again, eliminate. Sampling method is flawed and may produce biased results. So as I said that, it could. So let's keep that. Sampling method is not flawed and is likely to produce unbiased results. It could be flawed. So, eliminate that. So the best answer is C. By the way, I just noticed as I read it again, this is regarding something to do with the park. She surveyed people who go to the park. So of course this group of people that she surveyed will likely produce a biased result because they're already visiting the park. Let's say there's some people that never visit the park, so they don't care. So they might say, vote no, because they don't want to spend tax money on building more playgrounds on the park, because they don't even go to the park. So why do they care? Why do they spend their tax money on that? So that can explain why the sampling method is flawed as well. Okay. If x to the fourth minus y to the fourth is minus 15 and x squared minus y squared is negative 3, what is the value of x squared plus y squared? Oh, this is easy. X squared plus y squared, x squared minus y squared. I can factor this because this is a difference of two squares. So I can factor it like that. It's minus 15. And they give us that this portion is minus 3. So okay, so x squared plus y squared would be minus 15 divided by minus 3. which is 5. 11's A. Okay. Next, 12 and 13 refer to this. Cable company recorded the percentages of households in the U.S. that had cable TV from 1987 to 1997. In a scatter plot below, X represents the number of years since 1987, Y represents the percentage of households with cable television. The line of best fit for the data is shown. Okay. Which following is closest to the equation of the line of best fit shown? Okay. So the y-intercept looks like it's 54. Okay? So when x is 0, y should be 54. Not the case here, not the case here. Okay? And not the case here. So answer is C, right off the bat right there. Okay? And number 13, which of the following is the best interpretation of the slope of the line of best fit for these data? So can I squeeze both of these in on camera? There we go. Okay. A, the actual increase in the percentage of households with cable television each year. This is just interpreting what the slope is. The slope is change in y over change in x. So just even in terms of the unit, this is percentage over years. So the slope is the average rate of change of the percentage of households with cable television each year, basically. Okay, let's see what the choices say. The actual increase in the percentage of household with cable television each year, I wouldn't say it's actual. The predicted increase in percentage of households with cable television each year, that sounds more like it. Okay, so let's keep going though. Actual increase in the number of households with cable television each year. The y-axis is percentage, so for sure can't be actual, and then the number of households. And same for this. Predicted increase in the number of households, no, this is a percentage. Okay, so as I said, the actual would not be the answer in this case, because you can see the slope doesn't even cross through all the points. So the actual from here to here, you can actually measure. You just take the change in y and change in x. From here to here, you can get. From here to here, you can get. Or from this point to this point, you can get. But this is a line of best fit. It's the best fitting line through all the points. And then you can see it doesn't go through all the points. It doesn't go through most of them, actually. So it's only the predicted increase, not the actual increase. Okay, because you can see, if we use this line to approximate the percentage, even for year 1, it's an overestimate because you actually measured down here. Now in year 2, if you use the predicted, which is the black line, it'll be an underestimate because your dot is above the line. Okay? A greenhouse owner purchases fertilizer in 60-gallon drums. The fertilizer is mixed with water to make several batches of solution. Each batch of solution is made by mixing 3 quarts of fertilizer with water. What is the maximum number of batches of solution that can be made from one 60-gallon drum of fertilizer? So 1 gallon is 4 quarts also. You need 3 quarts for each batch. So that means 3/4 of a gallon for each batch. So it's how many batches can be made from here. So if we need, if there's 60 gallons, you divide by 3/4 gallon for each batch. So what's 60 divided by 0.75? 80. Answer C. Okay. Tara rode her bicycle along a straight road from her home to a restaurant and ate lunch. She then continued along the same road to a movie theater to see a movie. Finally, she returned home on the same road after the movie. Tara's distance from home during the first 4 hours she was out is shown in the graph above. How many total miles did she ride her bicycle? So this is distance from home. So from here to here, she rode her bicycle 3 miles. From here to here, she rode it 2 miles. And then from here to here, she rode it 5 miles. So 3 plus 2 plus 5, that's 5 plus 5, which is 10. Okay. Ryan has 1,500 yards of yarn. He wants to knit at least 2 scarves and at least 3 hats. Each scarf requires 300 yards of yarn. Each hat requires 120 yards of yarn. If S represents the number of scarves and H represents the number of hats, which the following systems of inequalities represents this situation? Okay, so he wants at least 2 scarves, so S is greater than or equal to 2. Only this has it. Eliminate this. H has to be greater than or equal to 3. This, and this have it. Okay, fine. Now, each scarf requires 300 yards of yarn, and each hat requires this. So, for all the hats or all the scarves he makes, he will need 300 S yards of yarn. And similarly, for each hat, if he makes H hats, he needs 120 times H yards of yarn. And he only has 1,500. So the amount needed for the scarves, each scarf, and the amount needed for all, not each, for all the scarves, and the amount needed for all the hats must be less than or equal to what he has, 1,500. Answer is D. Okay. Michael performed an experiment where he tossed 2 coins, 1 dime, and 1 nickel at the same time and recorded whether each one landed on heads or tails. His results are shown in the table below. For what percentage of the tosses did the dime Michael tossed land on heads? So how many tosses did he make total? We gotta sum all this up. It looks like it is 100. Because this is all very close to 25, so 25 times 1 was 100. Yeah, it looks like 100. And now, how many of those tosses did the dime land on heads? So it'll be both these cases. It doesn't matter what the nickel was, as long as the dime was heads. So it'll be 27 plus 26. So that is 53%, because there's total 100. That's the denominator. And the favorable was the dime was head, so that's both of these. That was 53, we said. Okay, so 53 over 100, 53%. During a storm, the atmospheric pressure in a certain location fell at a constant rate of 3.4 millibars per hour over a 24-hour time period, which the following is closest to the total drop in atmospheric pressure in millimeters of mercury over that course of 5 hours during the 24-hour time period. Okay, and then you got to convert. So this is where the calculator would come in, because it's not a nice number here to convert between. Okay, so let's use the units to help us out also. 3.4 millibars per hour for 5 hours, so 3.4 MB per hour times 5 hours, okay? And then times, we got to convert millibars to millimeters of mercury, mmHg. So that's right here. So I would put the 1013 MB on the bottom because I want to cancel the MB, this here with this there, okay? This here with, I don't know what I just said, but anyway, hope you got my point. And then I want 760 mmHg on top. So 3.4, plugging this to my calculator, times 5 times 760 divided by 1013. That is 12.75. Closest answer looks like is B. Okay. On its opening day, a car dealership had an inventory of 29 cars. During the first 6 months, 18 additional cars were purchased by the dealership each week, and the sales team sold an average of 15 cars per week. During the first 6 months, which the following equations best models the car inventory, C, at the dealership T weeks after opening day. So they started with 29. So when T is 0 weeks after opening day, so right on opening day, opening week, you would have 29 cars. So when T is 0, you would have 29. All of them look to be fine. Okay. So during the first 6 months, 18 additional cars were purchased by the dealership each week, and 15 on average were sold. So that means in each week, if they get 18 and they only sell 15, they will have a net of 3 extra. Okay, so the answer should be D, it looks like. Every week, every T, you would have an additional 3 extra. That's D. If 2 square root of 2x is a, what is 2x in terms of a? Oh, this is easy. So divide by 2 on both sides. Square root of 2x is a over 2. Square both sides now. 2x is a squared over 4. Answer is B. I don't know why they asked this. It was very simple. Okay. Lots of words in a diagram here. Project coordinator at banquet hall is given the task of arranging seating for an award ceremony. The figure above shows the first 3 possible arrangements of tables and the maximum number of seats in each arrangement. If the number of seats in each successive arrangement is increased by 6 over the preceding arrangement, which the following represents the maximum number of seats around n tables? Okay, so you got to model this. This is a sequence. You can model that as a function too. That's totally fine. Whoops. What does it say? So how many are here first? There's 8 here. Let me write it down. 8. Number of seats in each successive arrangement is increased by 6. So there should be 14 over here. 8 plus 6 is 14. Let's confirm. 12, 13, 14. Good. So over here should be 20. Let's confirm. This is 9. So 18, 19, 20. Yes. Okay. So we can write this as a sequence. So if we start with 1, so n is the number of tables. If you remember the general formula, it's like 8 plus the common difference is 8. So it'll be actually the common difference is 6. So it'll be like this. Okay, so if you remember, it's like a sub 1 plus n minus 1 times d, the common difference, that's a sub n. Okay? So I'm just using that formula. I'm a programmer, so I know this formula very well. 8 plus n minus 1 times d. So 8 is your first value. Okay? N is the number of tables. D is the common difference. To go each succession, it is plus 6. Okay, so if we simplify this, that's 8 plus 6n minus 6, which is 6n minus 2, plus 2. But we still don't have a matching answer because if we factor out the 2, it'll be 3n plus 1. And that's your answer, B. Okay? This is the way I thought to do it. Another way to do it is, well, you can use a linear model. Let's say this is 1, 8, 1 table, 8 people. And then you have 2 tables, you have 14 people. The slope is change in y, 6 over change in x, which is 1. Okay? You can use point slope form. Let me go down here. Y minus, in this case, up here, y is 8. The slope we set was 6 times x minus, there's 1 table there, so the x value is 1 there. Okay, and then you just solve like before. Y is 6x minus 6 plus 8, which is 6x plus 2, which is the same thing we got here, but one's n, one's x. Okay, again, factor. Same method. So sequence, arithmetic sequence, and a linear line, same thing. Just one's discrete, one's continuous. So not quite the same, but very similar. Okay, the graphs in the xy plane of the following quadratic equations each have x-intercepts of -2 and 4. The graph of which equation has its vertex farthest from the x-axis? So if you have a graphing calculator, I think those are allowed still. You can totally graph all these, but that would take some time. The way to do this by hand is you don't want to change this all into standard form and then do negative b over 2a to find the x and then find the y afterward. You got to be a little smarter than that. This is a time test. What's the x-intercept if we know what's the x value of the vertex, x-coordinate of the vertex if we know that x-intercepts are -2 and 4? The vertex would be in the middle, right in between the two x-intercepts. So what is the x value there? That would be the average. So x would be -2 plus 4 over 2, which is 1. Okay? So that would be your x value, x coordinate of your y-intercept. So let's plug this into the view. So let's draw a line. When x is 1, what do we get here? We get -7 times 3 times -3. Okay, did I do that right? -7 times 3 times -3. Okay, let's simplify later. 1/10 times 3 times -1. Over here would be -half times 3 times -3. And over here would be 5 times 3 times -3. Why did I do -1 here? The x-intercepts are the same. So it should have been -3 here as well. Okay? So we didn't even really have to write all this. I'm just here to show you that since they are all in factored form, only this guy out in front really matters because everything here would be the same. Because the vertex must be at x is 1. They gave us the x-intercepts there. So when you plug in that value of x, they'll all be the same. And what's the big determining factor is out here, actually. You kind of need to know the value that it would be -9. You need to know that's negative because the sign might matter. Okay, so what's the biggest value here? Honestly, it looks like A. That would be furthest away from the x-axis. So actually the sign doesn't matter. If we take the absolute value, because it's distance, furthest away. We don't care if it's upward or downward. We just care that's the furthest away. So this one looks the biggest. And that's the answer. Hopefully that made sense. Okay, next. In the system of equations above, C is a constant. For what value of C will there be no solution to the system of equation? Okay, so when there's no solution, that means the lines are, there's two linear lines, the lines are parallel. Okay, they're not the same line either. When they're the same line, they have an infinite number of solutions. Okay, so let's write it in slope-intercept form, both of them. So this first one would be y is 5 minus 2x over 3, which would be minus 2/3 x plus 5/3. Okay, the second one would be y is 8 minus 4x over c. Okay, that's 8. Let me change the order. Minus 4 over cx plus 8 over c. Okay, so we want these two to be the same. Minus 2/3 is minus 4 over c. The negatives will cancel to both sides can be positive. And then let's multiply by c on both sides. So 2/3 c is 4. Then multiply by 3/2 on both sides. So what is that? C would be 6. Okay, so that should be the answer. Let me check. Yes. Okay. Once again, the key here was when there's no solution to this system of linear equations, the slope must be the same. The polynomial p to the fourth plus 4p cubed plus 3p squared minus 4p minus 4 can be written as p squared minus 1 p plus 2 squared. What are all of the roots of this polynomial? Okay, so this one we can factor as p plus 1, p minus 1. And this other one we cannot factor anymore. So the roots are -1, 1, and -2. 24 is C. Okay? Which the following describes an exponential relationship between the pair of variables listed. Okay, for every 3 ml increase m in the thickness of a piece of glass, the intensity of light I traveling through the glass decreases by 20%. That sounds exponential already to me, because it keeps decreasing by 20%. So you're going to multiply by 0.8 times 0.8 times 0.8. So that's exponential, 0.8 to the x, something like that. Each second as car speed c decreases at constant rate, that's already not exponential. Eliminate, that's a linear model. With every 33-foot increase in depth, d, below the surface of water, the pressure of an object increases by 14.7 pounds per square inch. This sounds linear as well. With every 33-foot increase, it's this much. So another 33, it's another this much. That's a linear model. The depth of water remaining in a reservoir decreases by 15 inches each minute as the water is being pumped out at constant rate. That's linear. Answer is A, as I predicted. Okay. Powering through. Researcher is investigating the relationship between the price of a 4-pack of AA batteries at a convenience store and the number of comparators the store has. She defines the store's comparator as another similar store within a 1-mile radius of the store she selects. She selects 32 convenience stores across the state at random, and for each store she records the number of its comparators and its price for a 4-pack of AA batteries. The results are shown along with the line of best fit in the scatter plot below. Okay, so the lots of words, maybe a lot of it's not relevant, so we'll review it if needed. Another convenience store in the same state sells a 4-pack of AA batteries for $49. If the store's price is more than that predicted by the line of best fit, what is the least number of comparators the store could have? Okay, so this is saying 489. 489, what are the tick marks? So you can see how I'm thinking through this. 1, 2, 3. So this is about 20 cents each, so 420, 440, 60, yeah, 20 cents each. 489 will be somewhere here, because that's close to 4.9. Okay, so let's draw something like that. Okay. If the store's price is more than that predicted by the line of best fit, so the line of best fit is here, store's price is more, so the price is here. So it's one of these 2 points. What is the least number of competitors that the store could have? Actually, let's just draw the whole line. Okay. So it's actually one of these 2 points. Okay? Because this is a measurement, 489. So these are measurement points. So if 489 is here, this particular store that's represented by this black dot is 489. This one also, okay? Now, this store would have 3 comparators. This store has 4 comparators, okay? So the answer should be C then. Is that right? Let me double check. I feel like it's too easy. Oh, it is. Okay. Yeah, don't gotta overthink this. Okay. So once again, so my mistake here initially, as before I thought about it a little more, was the part they might be tricking you on is here when it says more than that predicted by the line of best fit. So you would be tempted, like I was, to think this point of intersection here, so one of those 2 points. But when it started saying what's the least number of competitors, well, these have the same number of competitors. So that doesn't sound quite right. Why does it say least? So that's when I drew the whole line, and then I realized, oh, we got to pick one of these 2 points. These are measurement points of 489. Okay. The line of best fit passes through 18 minus 0.12, which the following can be concluded from this. Okay. The line of best fit will not model the price well for a store with a large number of competitors. I feel like that's true because if there's 18 competitors, how would a store be able to price it at negative? So they're paying you to buy the pack of batteries. So you're not really buying it. They're paying you to do it. So that's what this point is kind of saying. So A sounds to be correct. Let's move on though. A convenience store with 17 competitors can no longer sell 4 packs of batteries. How would you be able to conclude that? No way that you can conclude that. I mean, just because you just think in the real world, if you have 17 competitors, why would that stop you from selling your thing? You just got to price it competitively. Convenience store with 17 competitors cannot decrease its price any further. Not necessarily true either, because it's really dependent on how the other competitors price. Okay, let's say it flattens out already at 6 and it's continuous afterward. We don't know. Convenience store cannot have more than, oh, that's for sure not true. How can you conclude that from the model? Answer is A. So some of these don't even make sense. So really not having to do with math at all. It doesn't make sense in the real world. Okay? Next. Figure above shows that the shaded triangular region with a hypotenuse of 5 centimeters has been removed from a rectangular tile with dimensions x by y. Of the following, which best approximates the area in square centimeters of the tile before the piece was removed? I feel like we just got to use special right triangles here. 30, 60, 90 triangles. Okay, so if this side is 50, and because this is a right triangle with a degree of 30 over here, so this one's 60. If this is 5, how would that help us? We need to get y and x. So let's find this side then. This side would be 5 root 3. Okay? And if this side is 5 root 3, there's another 30, 60, 90 triangle right here. If this side is 5 root 3, that's the hypotenuse of this triangle here. So then this side would be 5 over 2 root 3. And this side would be 5 over 2 root 3 times root 3, which is 15 over 2, because 5 over 2 times 3 would become. Okay, so that's 15 over 2 over here. We found that. Now we got to find the x. Okay, so this side would be 5 root 3. No, that's not right. This side would be 10, because this is the hypotenuse of this triangle, this middle one. Okay, if this is 10, this is also a hypotenuse for this triangle, so this would be the 5, and this would be 5 root 3. Okay, so the area would be, this is 7.5, 15 over 2 times 5 root 3, if I did it correctly. So let's punch it into the calculator and see what I get. So, I need my scientific. So root 3 times 5 times 7.5, I get 64.95. Is the answer D? This is what, 28? Yes. So this is all about special triangles here. Okay, 2 more multiple choice and then free response. We're chugging along. Thomas is making a sign in the shape of a regular hexagon with 4-inch sides, which he will cut out from a rectangular sheet of metal, as shown in the figure above. What's the sum of the areas of the 4 triangles that will be removed from the rectangle? Okay, so we probably can just find, since this is a regular hexagon, we could probably just find the area of one triangle and then multiply by 4. Okay, so how does it help us when it's a regular hexagon? Well, we can piece out one triangle. Okay, what's this central angle right there? The whole, if we keep drawing triangles like this, with sides connected to the corners, you would have 6 angles. Not a coincidence that it matches the number of sides. So if it's a regular polygon, then each angle would be 60 degrees because they would total 360. And then there's 6 of them, so divide by 6. So this would be 60 here. All right? And because it's a regular polygon, we can, if we bisect it, this will be 30 there. Okay? We bisect it, so this originally was 4, to tell us that. Then this would be 2 over here if we bisect it. Okay? Again, this is a 30, 60, 90 triangle, so if this side is 2, then how does that help us though? I just start going through the motion. Oh, because we need this and we need this. So how does this help us? Okay, let me finish first. I feel like we need it. If this is 2, then this is the hypotenuse, which is 2 times of that, which is 4. And this height would be 2 root 3, because this is opposite to 60 degree. Okay? So how does that help us? So if I keep drawing the triangles, if I just draw it like that, this right here, we can find, because this is also the triangle with 60. It's a regular hexagon, so all these triangles are identical. And we already found what this is right here. It is 4. So this is 4 over here, and as well over here. Okay? And so this whole side would be 8. Okay? Now this piece is 4. The whole thing is 8. You can assume these are symmetrical because it's a regular polygon once again. So what's the difference? 8 minus 4 is 4. So there needs to be 2 here and 2 here as well. Okay? So we found half the battle. We need this now over here. How do we find that? Well, okay, let me draw one more triangle here. So this is 4. This is it says it's a rectangle, right? So it's a rectangle there. We can find the side by Pythagorean theorem. So it'll be, if we call that x, 2 squared plus x squared is 4 squared. Okay, so x squared would be 16 minus 4, which is 12. So x is square root of 12. Okay, which is, if we simplify that, that's 12 is 3 times 4, so that's 2 root 3. So the area of one triangle would be half the base, which is 2. The height is the 2 root 3. 2 root 3, which is 2 root 3. This is the area of one triangle. So 4 triangles would be 4 times 2 root 3, which is 8 root 3. The answer is A. Yes, that's right. Okay, you can see these are gradually getting a little bit more challenging and involved. So supposedly this should be the hardest one for the multiple choice, but let's see. Sometimes it's not. Which of the following equations describes a circle with radius 10 that passes through the origin when graphed in the x, y plane? So radius of 10, so that means the thing over here, remember in standard form of a circle, is your r squared. Radius is 10, so radius squared, r squared, would be 100. So it's one of these 3, eliminate A right away. Okay. It passes through the origin. So be careful. It doesn't say the center is at the origin. For sure, that's not one of the choices, right? If it passes through the origin, that means the origin is on the circle. So if you plug in 0, 0, the equation should hold. Okay? Which one would be true for that? Let's check. Like, for example, this would be 5 squared plus 5 squared. That's be 25 plus 25, that's 50. Not the case. Cross that out. Same for this, that would be 100 plus 100, which would be 200, which is not 100. So that by process of elimination, it will be D. We can even check. It'll be 5 root 2 squared. What would that be? That would be 25 times 2, which is 50. So 50 plus another 50 for sure that's 100. That's how we do that one. See, this is not actually the hardest one. But usually, as you progress sequentially, the last ones are usually the harder ones. At least when I took it, it was the case. I'm not sure if it is still the case now, but it seemed like it so far. Okay. Now we have the free response remaining. Let's finish this up. It's almost an hour already. In the xy plane, this parabola is the image of the graph, this guy, after a translation of how many units to the right. Okay, so this one, so remember shift right, left has to do with what's attached to this x. Okay, you can notice that's the only thing that changed. So this one is from the parent function. I'm going to reference this as the parent function. This is shifted to the right by 6. This is from the parent function shifted to the left by 5. So to go from this to this, you would have to shift right to the 5, right by 5, shift to the right by 5 in order to get back to here without the vertical translation. To get back to here, you need to shift to the right by 5, and then you have to shift to the right by another 6. So 5 plus 6, 11. When 9 is increased by 3x, the result is greater than 36. What is the least possible integer value for x? So 9 is increased by 3x. That's 9 plus 3x. The result is greater than 36. Okay, so we just solve for x here. 3x would be greater than 27. Okay, x is greater than 9. Okay, so be careful. Your answer is not 9. It has to be greater than 9. Least possible integers, the next one would be 10. That's how they probably will trick you here. It's not 9 because it cannot be equal to 9. It says right there, x has to be greater than 9. So what's the next integer value? 10. Okay, the table above shows the distribution of US presidents according to the century and the region of the country in which they were born. Based on the information in the table, what fraction of presidents who were not born in the 19th century were born in the South? Okay, so how many presidents were not born in the 19th century? What fraction of presidents who were born? Yeah, who were not born. So this is conditional probability. So how many presidents were not born in the 19th century? That would be everything but this. Okay, so you got to add up all these other ones. So this is 14. This is what? 10. So it's 24 total that are not born in the 19th. Okay, now of those 24, how many were born in the South? Of those 24, how many were born in the South? That's 9 plus 3. That is 12. Okay, so that's the fraction, which is half. Okay, so that's your answer right there. You could either put this in or 0.5. I would put this in because it's a fraction. But according to the answer key, also accepts 0.5. Okay, if x is not equal to -1, what is the value of this guy right here? Okay, so this one, I could already see, you could factor out a 2. Okay, then these would cancel, and you're left with 2. As simple as that. A few more. The price of a ticket to a play is based on the row the seat is in, as shown in the table above. A group wants to purchase 10 tickets for the play. They will purchase 3 in seat 1, 3 seats in row 1, 2 in row 3, 2 in row 4, 3 in row 12. What is the average ticket price in dollars for the 10 tickets? Describe the dollar sign when giving the answer. Okay, so they'll purchase 3 tickets for row 1. How much does it cost for row 1? 25. So 25 times 3 plus, we're finding the mean. So that'll be 25, 25, 25, and then 2 in row 3. So 20, 20, 2 in row 4, 20, 20. So there's going to be a list of numbers, and we're going to add them all up. So might as well do the 3 that are in row 1, do 25 times 3, because you're going to add 25, 25, and 25. That's 25 times 3, or 75. Okay, so 2 in row 3, so 2 times 20, plus 2 in row 4, so 2 times 20 again, and then 3 in row 12. Row 12 would cost $15 each. How many are total? That is 10. Okay, so that would be your average. So you got to plug this into your calculator now. That is 75 plus, 75 plus 40 plus another 4, that's 80. And that is 45 divided by 10, which is 20. The average ticket price is 20. A fashion buyer for a large retail store purchased 315 items directly from the manufacturer for a total of $6,000. Some of the items were dresses purchased for $25 each, and the rest were shirts purchased for $10 each. How many more dresses than shirts did the buyer purchase? This is the systems of equations. You guys set up 2 equations with the 2 unknowns. Okay, so if D is for dresses, S is for shirts, D plus S, there's 315 items total. And they tossed a total of 6,000, and then dresses were 25 each, so 25D plus $10 each for each shirt, so plus 10S is 6,000. Okay? If you have a graphing calculator, you can just graph these 2 equations and find the point of intersection. If not, you got to do a little more work. Let's rewrite this as, I'm going to use the substitution method. How many more dresses than shirts? Okay, so we got to find both. There's no way around it. Okay, so yeah, okay, let's just find both. Okay, so S would be 315 minus D. So plug this into here. 25D plus 10 times this, so that'll be 3150 minus 10D is 6,000. So my D would be, that's 15D is, what's 6,000 minus 3150? That's 2850 divided by 15. So D is 190. If D is 190, plug into this one, or plug into right there. S would be 315 minus 190, which is 125. Now you got to answer the question, how many more dresses than shirts did the buyer purchase? The buyer purchased how many more dresses here? It looks like 65. Okay, let me check. Yep, that's the answer. System of equations. Okay, last 2. Let's finish this up. Instrument shows the number of revolutions per minute made by each tire of a car. In each revolution, the car travels a distance equal to the circumference of one of its tires. The circumference of each tire is equal to 2 pi r, where r is the radius of the tire. Yes, that's assuming the tire is a circle, right? If the radius of each tire on Maria's car is 0.3 meters, what is the approximate speed of Maria's car to the nearest kilometer per hour when the instrument is showing 779 revolutions per minute? So we can use unit analysis here to help us out. So it's asking for speed. So revolutions per minute is the speed, but they want it in kilometers per hour. That's the only challenge. You got to convert revolutions per minute to kilometers per hour. So 779 revolutions per minute. Okay. In one revolution, how many meters is it? It would be 2 pi r meters. One revolution is one circumference. So 2 pi r meters. And it's 0.3 meters. So it'll be 2 pi times 0.3 meters. That's the unit m over there. And then we got to convert to kilometers per hour. So we got to convert meters into kilometers and then minutes into hours, okay? So, and there's 1,000 meters in 1 km, and then there's 60 minutes in 1 hour. This is why I like to do it like this. I can see all the units. Revolutions would cancel, meters would cancel, and then minutes would cancel. So you have km per hour, which is what the question's asking. So now let's plug it into the calculator. It would be Where's my calculator? It'll be 779 times 2 times pi times 0.3 times 60 divided by 1,000. So this is 88.10 blah blah blah. It says to round to the nearest kilometer per hour, so it should be 88 kilometers per hour. Yep, and that's the answer. Okay, so this is where units can help. Okay, Maria gets new tires for a car. The radius of each of her old tires is 0.3 meters, and the radius of each of her new tires is 11% larger than the radius of one of her old tires. What is the circumference of each new tire to the nearest tenth of a meter? So radius of the old is 0.3. Radius of each of the new is 11% larger. So the new would be 0.3 times 1.11. Okay? So 0.3 times 1.11, that is 0.333, unsurprisingly. Okay? So this is the new radius. I call it n. I should have said like r new or something like that, but that's fine. So circumference of each tire. Circumference is 2 pi r. So this r is 0.333. So 0.333 times 2 times pi. What is that equal to? That is 2.09, so it should be 2. That should be your answer. Nearest tenth, sorry. 2.09, so 2.1. That's the answer. Okay, so be careful for rounding. So I made a mistake right there. Okay, and that's all. So I solved this in about an hour. I actually don't know how long they allow for this exam. Let me peek real quick, so see how I did. "55 minutes. Oh, okay. So because I was going slow to explain, I guess I went about 10 minutes over. So not bad. So for sure, if I didn't have to explain all that and didn't have to show as much work, I would have got it. But I'm not the one taking the test. You probably are. So hopefully this was helpful for you if you even just needed the problems to practice, or if you tried it and you were stuck. Hopefully, as I solved and thought through the problems, maybe you got some insights to how to do it the next time. Okay, as always, please like and subscribe if you found this helpful.